Hello everyone, welcome back to my channel. Today let's go over a medium question that took me a very long time, but I finally managed to solve it on my own, so I'm really happy about it. As you can see, lots of trial and error, but finally managed to eke out a solution that passed in the bottom 5%, so very happy, and let's go over it. So basically you're given an integer array nums of length n and positive k. You want to find conditions of every subarray of size k, making sure, one, that they're consecutive and sorted. If that's true, return the maximum element of the subarray. Otherwise, return -1 for that particular subarray of length k. So here is consecutive and sorted, so 3. Here is consecutive and sorted, so 4. Here is not consecutive, but and not sorted, so -1. Same here, not sorted, -1, not sorted, -1, and also not consecutive for both of those. So let's declare an array because we're going to return that at the end. And let me show you my brute force way, which didn't work, but I tried for a long time. And then let me show you my optimized solution that I finally came up with. So I in range length nums minus size plus 1. Subarray is nums of I plus size. So we're just getting every subarray of size k, right? And then let's just say if subarray is equal to sorted subarray, right? Sorted and they're consecutive, so all of subarray j is equal to subarray of j minus 1 plus 1, because this guy has to be 1 more than the previous for it to be valid. This guy has to be 1 more than the previous to be valid, and vice versa. This would not be valid because 3 is not 1 more than 4. In that case, then we can append max of subarray, right? The maximum element of that subarray, which is 3 in this case. Otherwise, if there's any violation, append -1. So technically this works, but plus 1 for j in range 1, length of subarray, going from 1 to the end, comparing to the previous. So this technically works, but it's going to be really slow. So let me show you my own better way. Okay, so time limit exceeded. The idea I had was that we can pre-compute the values. So let's take this, for example. If we take this input, we observe that this has to be 1 more than the previous. So why don't we just pre-compute this? For I in range 1, length nums, and let's call this the status. At each position, it's going to be good or bad, because either we're violating a condition or not, and we're starting from 1 to the end, comparing the previous. So if nums of I is equal to nums of I minus 1 plus 1, then the current is valid. So we're going to append good to status. Otherwise, right, because if it's 1 bigger than the previous, then that's also classified as sorted as well. So 2 birds with it knocks out both conditions. So satisfies both conditions. Otherwise, status.append bad, right? So what this is going to do is just pre-compute exactly what's a good subarray and what's a bad subarray. So as you can see now, we get this. And what we want to do now is to compare, because, for example, the first subarray is going to be good, the second subarray is going to be good, but the third is not, because 1, 2, 3. We have to do some modifications to this as well. So let's see here. So I'm trying to think about how I modified this. Equals to nums of I minus 1 plus 1. So, okay. So I think the idea is that we are going to actually go through and check, for example, for I in range length nums minus size plus 1. So subarray is going to be nums of I plus size. And we're going to check the current is going to be status of I plus size minus 1. So let's print the subarray and current. So now you can see that this is good, but this has one B, so it's bad. This is all B's, bad, bad, right? All these are bad, all these are negative ones. So we're gonna actually just go for the first two instead of, we're gonna go for the first two for status, right? Because we're already skipping one element. So here, bad, 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 good. Here, bad, good, bad, good, bad. Bad, good, bad, good, bad. So I took a lot of trial and error, but I finally just said, okay, that looks right. So let's go with this idea. And again, if there's a bad inside of the subarray of the current, then we're obviously just going to append -1. Otherwise, we're going to append the maximum of whatever we have, which is 3 and 4. So, okay, so if B is in current, then result.append -1. Otherwise, result.append max of subarray. So this is still going to be too slow because these are line 16 and 21 are both N, although it technically works. This is N, 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 which is not good. So how do we take care of it? Let's fix this. How do we fix this? This is going to be tricky, but we use a dictionary to basically go over status. So this is going to be a valuable picture that we can use. Okay, so counter of nums of status of everything up to size. Let's print C. So size -1, because the first one is going to be 2. So as we slide forward by 1, we're going to get rid of this one and add this character. We're going to get rid of this guy, add this one. We're going to get rid of this guy, add this one. We're just going to slide one at a time so we don't have to check in, because in is also N in time complexity. And first, what we're going to do is, instead of max subarray, we're going to use a sorted list. So SL equals sorted list of nums of everything up to K. So we're just going to find the maximum of this in log n time instead of n, which is max is n. And the way we're going to do that is, again, one at a time. So let's call this before is I, after is I plus size. Let's print before and after. Again, this just takes a lot of trial and error. So is this correct? We are going to have, okay, let's print SL 1, 2, 3. Okay, that's correct. So for 1, 2, 3, let's get nums in here. We're going to add 3 and remove 0. Yes, that looks correct. We're going to add 4, 0, 1, 2, 3, 4, and remove 0. Yes, that's correct. So we want 3, 3, 4. Okay, so we know how to build our sorted list, and that's great. So we're going to say if sl.remove nums of before. If after is less than length of nums, then sl.add nums of after. Let's print SL and subarray just to make sure we're doing it correctly. Now they should line up, which they don't, because I did it one turn early. So let's see here. We should do it after, because that's the first turn, 1, 2, 3. Okay, so now they line up, and you can get the maximum just as -1, right? So the first turn was already here. That's why we moved this down here. And result.append SL of -1. So that's going to be a little bit better, but still not enough. Okay. This is still n, this is still n. So now let's build a dictionary to take care of this, to roll this forward one at a time as well. And that's going to be a bit more challenging because first we have G2, that's fine. But so let's say, so this before is for the sorted list, but the other is, let's call this before counter. After counter is going to be I plus size -1. Let's print BC and AC. So BC is going to be removing 0, adding 2, and then removing 1, adding 3. Yes. Removing 2, 0 and 2, adding 4. So BB, yes. Removing 3, adding 5, BB, yes. And then, yeah, as long as this is less than 1, 2, 3, 4, 5, 6, I think we can do that. And we also do that below here. So if BC is bigger than or equal to 0 and BC is less than length of the status, that means we can C of status BC minus equal to 1, shrink in the window from the left. If C status BC is equal to 0, then delete it. We're going to try to make this O1. If C and then C status AC plus equal to 1. Okay, so if AC is bigger than or equal to 0 and AC is less than length of status, again, to do that, so let's print C and let's also print current. That's what we're comparing it to. So C, so GG, GG, this should match up, it's not. So that is a problem. Perhaps we should put this up here. Current, let's make this up here. Okay, so we got the sorted list out of the way. We don't care about that. So let's see what's going on. This is fine. I guess we're still starting 1 too early. So perhaps we could move this over here. So GG, that's fine. This is fine. We just want this, and then this reflected. Sorry, I can't talk in a dictionary. So this is fine. Why is this not fine? Maybe we should print C and cur here 1 turn earlier. Okay, yeah, 1 turn earlier because the first turn is reflected here. That's the first subarray. Okay. And then that makes it, let's also print. Okay, so now maybe we can just do it here. So we move this up here instead. And okay, output limit exceeded. I think we got it. So this is still not okay because that's n and that's n. So what we're going to do, because we don't need this anymore, and we don't need this anymore either, because for B and C, this is ov1, this is a dictionary, because we deleted it if we got to 0 for the frequency. And this is where I'm talking about, because let's print BC and AC. This is an edge case that I ran into. So if AC minus BC is less than or equal to 0, then we can just append SL -1. Okay, so because they're the same, so literally the subarray, the status subarray doesn't even exist at all. So then we're always good. So we're not violating any condition. So we just append the maximum, right, of whatever that subarray was. And it takes a bit of trial and error to find that out. Okay, still time limit exceeded. Okay, so what's the next step here? Why are we doing it here? We can do it here instead. Let's put these together, the sorted list versus the dictionary. Oh, sorry. We don't need cur now because that's the whole point. This is n itself, which is the problem. Because we already did this with the indices. There you go. See? Because we already, basically this is already the boundary of whatever we have in the status array, right? The start and the end. So that's a huge time saver. So O of 1, dictionary, and then sorted list to find the maximum of the subarray with n log of n. And yeah, so this is pretty messy, but it took me a while, but I'm pretty happy again. So thank you for watching and stay tuned for more.